Hi everyone! This week we are going to focus on the second part of the NIET rubric, or part 2 of this series. Last week I introduced you to the rubric and we discussed the first half of the rubric. This week we're going to go over the second half of the rubric, which includes thinking, problem solving, instructional plans, student assessment, and environment. So the first portion of the rubric we're going to discuss is thinking. And you're probably wondering, well, how do you assess how I'm teaching thinking, right? Like, how do you do that? Well, there's 4 ways to teach thinking. You can teach your students how to think in a couple different ways. One is questioning, getting your students to start doing some higher level questioning. Your learners must be presented with problems and questions to which the answers are not apparent. You can also model. So emulating others is a basic way of learning. You can model what you expect. Do not be a do as I say, not as I do educator, right? Sometimes we do that. But in most parts, we can model inquiry-based thinking. We can model coming up with variables for experiments. We can model different ways of thinking as well. Another way that you can teach thinking is the way that you respond. Give your students plenty of time to think and give them time to really think about the answer. If you're doing that higher level questioning in your class, your students need a minute to come up with the answer. Accept all answers without judgment. I know we always joke about some of the funny things our students say in our classrooms, but we need to make sure we work on our faces and our tone of voice, even if they have some really wacky answers. I think it's so much fun when we do this in elementary school because they come up with some really awesome off-the-wall answers, and you have to make sure that they still feel like those answers are legit. Clarify when you don't understand. So instead of just like breezing past a student who's probably trying to explain something and might not be using the jargon correctly or might not be expressing themselves correctly, take a minute to really clarify and understand your students and provide real academic feedback and empathize with them. And finally, if you structure your lesson in a certain way, it's also going to enhance thinking. Make sure your expectations of your students are clear. Thinking happens throughout the school day, across content areas, and over extended periods of time. And you need to give your students opportunities to interact with each other and to think about the different ways that they can express themselves in the way that they think. So some of our students might be better writers. Some of our students might be better at speaking or presenting. And some of our students are going to be a little bit more analytical, whereas others may be a little bit more qualitative. So the way to earn a 4 or 5 in thinking is the teacher thoroughly teaches 2 or more types of thinking. And what's great about science is this is easy. So you need to just make sure your students are doing 2 or more of these types of things. Analytical thinking, where students analyze, compare, and contrast, and evaluate and explain information. Practical thinking is where students use, apply, and implement what they learn in real-world scenarios. Creative thinking is where students create, design, imagine. And research-based thinking is where students explore and review a variety of ideas, models, and solutions to problems. So here's an example. If you're teaching weather and weather patterns, which happens in elementary, middle, and high school in Louisiana, analytical thinking could be students comparing rainfall and temperatures across various parts of the state or across various parts of the country. Practical thinking is where they could use a real-world scenario. One of my favorite weather lessons is where students have to discuss what they would pack if they were to travel to various countries during various times a year. Creative thinking is where students create, design, and imagine. This could be where an area is experiencing a drought. How would you still get water to your different agriculture fields? And research-based thinking, maybe that's where you start exploring the idea of climate change or understanding why certain areas in Louisiana flood and other areas do not. or the diversions. So there's a lot of great ways where you can incorporate different types of thinking into lessons and units in science. You need to be able to provide opportunities where students can generate ideas and alternatives. An easy way to do this is just by asking your students to come up with alternative experimental designs. You could also have your students analyze problems from multiple perspectives and viewpoints. I know we do this a lot in ELA in Louisiana, but you could also do this in science, looking at the advantages and disadvantages of various solutions that your students come up with and who would benefit from those. And you can monitor thinking to ensure that they understand what they are learning, are attending to critical information, and are aware of learning strategies that they are using and why. So maybe asking them, how did they figure this out? How did you come up with this model? How did you come up with a solution? Now, monitoring thinking sometimes can be a little bit difficult, so I'm going to show you guys a tool in just a minute. So examples of various types of thinking. You have practical thinking. This is the application of a scientific concept in the real world. So how do batteries work and why storing them in the freezer does not change their shelf life. You can create and design a food chain with imaginary animals and provide a rationale for where each animal fits. How cool would that be for ecology? Research-based thinking. Research 3 sources of alternative energy and based on your analysis of each, recommend which one is the most fruitful source in Louisiana. You could generate ideas and analyze data. Each group tests different variables for the same science experiment and compares the results, like how to get your tomato plant to grow the tallest. And monitoring students' thinking, this is where I would recommend you use Paige Keeley's science probes, which I'm going to show you on the next page. And you can Google these. They are available in a lot of libraries, and you can also purchase them off of Amazon, and some school districts will buy them for you. So this is an example of a science probe. And what I love about these science probe books, which are written by this woman, Paige Keeley, is that they tell you how to use them for each grade level. So you can use these starting in kindergarten. You would obviously have to modify them tremendously because our students don't know how to read and write very well at those lower age levels. But they even tell you how to modify them for middle school and high school. And I'll tell you this, the Louisiana LEAP test and a lot of these probes look very similar. So I would highly recommend that you consider using them. I like to use them in a couple different ways. Sometimes I like to use them as kind of like a pre-assessment to see what prior knowledge my students are bringing into the lesson. Sometimes I like to use them as a formative assessment to kind of see that everyone's thinking on the same page or if there are some major misconceptions happening in the middle of a unit. And then sometimes I like to use it as a summative assessment and see if my students really pick up what we're putting down during the lesson. You could use it as all 3 actually. You could do like a little pre-test and post-test. And I really love it when they give you 4 or 5 options for answers. This is an example where this looks more like a CER for the LEAP exam. But a lot of them also have like A, B, C, or D. And then I like to have my students get in the groups. And everyone who picked A and everyone who picked B and C and D, they have to write down the top points of why they picked these answers. And then they have to debate amongst each other why their answer is correct compared to their neighbors. And it's really a wonderful way for you to formatively assess your students and understand where they're thinking and what you might still need to go over because there might be some misconceptions. So here's an example. This is called the virus debate. And the students in Mrs. Olivier's biology class were having a debate about viruses. Half of the class thought the viruses were considered living things, and the other class did not think the viruses were considered living things. Which side are you on? And then explain your thinking. Now, here's the thing. First off, you get that immediate formative assessment of, does my student believe that they are living or non-living? But then what's really wonderful is you have your students write and explain their thinking. And that's such a beautiful snapshot into their brains as to what is really going on and understanding their thought process behind this particular concept. FYI, this is a huge debate, but viruses are not living. I'm sure someone on my YouTube channel will comment about that. but they are like parasitic particles that need to use the cell to replicate, but they can't replicate on their own. They have to use the cell's ribosomes to make proteins, and they have to use the cell's plasma membrane to coat themselves, etc. So this is just one example of many, 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 many probes. And the best part is she makes probes for every type of science: chemistry, biology, physical science, astronomy, geology, and for every grade level. So if this is something you're interested in, I highly recommend checking them out. You can always email me and I can send you some more examples, and you can come by my office and borrow and photocopy a few too if you need to. The next section on the rubric is problem solving. This is your students developing multiple skills in problem solving, and this enriches the learner's ability to manage complex tasks and higher levels of learning. Think the higher levels of Bloom's taxonomy, that evaluate and analyze section. Also, we want to see that the teacher empowers the students with problem solving skills. So we're not just going to hand them the answers. So examples of a teacher who would score a 4 or a 5 on the rubric in this section is the teacher implements activities that teach and reinforce 3 or more of the following problem-solving types. Now I know what you're thinking. Hollander, I have 50 minutes to teach. You're going to come observe me, and I need them to see 3 or more of these things. It's okay if we don't. I understand that during a unit you might do 3 or more of these. So these are abstraction, categorization, drawing conclusions or justifying solutions, predicting outcomes, and observing and experimenting. I mean, hello, we teach science. What a beautiful place for problem solving, right? I mean, I think about categorization and just teaching in elementary school and middle school different types of cloud formations, animals, food webs, elements in chemistry, types of rocks in geology. You can do all that in categorization. You can have students drawing conclusions and justifying solutions based on experiments they observe or do. And obviously, you can always have your students observing and experimenting and predicting outcomes. So here's a great study involving weather. Again, like I said, we see this in elementary, middle, and high school. After a study of yearly weather patterns, students will keep a daily weather record for 1 month, noting the date, type of weather, temperature, amount of precipitation. They will also create their own rain gauges to measure the precipitation. How awesome would it be to have your students measuring the amount of rain that fell at their elementary school and then comparing that to what Margaret Orr reported on that evening on the evening news? And then at the end of the month, they will determine the median and mean for temperature and precipitation. And using this data and their knowledge of yearly weather patterns, they will hypothesize whether the medians and means for the next month will be the same, higher, or lower. I also really like using almanacs for lessons like this, and you can have your students compare the data that they collected or the year before, the class from the year before's data to their data, as well as the almanacs to see if the almanac predicted correctly the weather during that time. Another section on the rubric is instructional plans. And you're probably wondering, like, really, Hollander? You're going to evaluate that? And we are. Next week, I'm going to start the 5E instructional plan guidelines for you all so you understand exactly how your instructional plans need to look for our class. But what I need to see is that your instructional plans include measurable and explicit goals aligned to the state content standards. Isn't that what we have to provide to our administrators? Also, activities and materials and assessments that are aligned to those state standards. So I need to see that everything you are doing goes back to the Louisiana state standards. I need to see that everything's sequenced correctly, right? We can't just go from 0 to 60. We need to scaffold our lesson in a way where we are teaching sub-objectives and there's a logical progression in what we're teaching. I want to see that you're building on students' prior knowledge and making the lesson relevant to the students' lives. Again, this is similar to that motivation and knowing your students section of the rubric, and providing appropriate time for student work, student reflection, and lesson and unit closure. So of course we have to provide enough time for your students to do the assignments and activities, as well as to reflect and think about what they learned and how they learned. Evidence that plan is appropriate for the age, knowledge, and interest of all level learners, right? We want to make sure that everything's not too easy or too hard, and the evidence that the plan provides regular opportunities to accommodate individual student needs. So obviously I'm going to need to see accommodations for your students with learning disabilities, English as second language, your higher achieving and lower achieving students. Interestingly, and what I really like about this rubric is, as an observer, I need to walk around and look at student work. And we actually evaluate the student work. Now, when I'm evaluating the student work, I'm not evaluating if your students are getting it right or wrong. I would just really like to see what you are asking of your students. Like, what are the assessments? What are the activities that they're doing? How are they collecting their data? Where are they writing down their answers? Of course, I'm going to be asking your students things like, why are we learning this today? So can you explain this in your own words to really see if they are understanding the lesson? Any assignments should develop so that they are aligned to pre and post tests, which should be aligned to high stake tests. So what does that mean? That means that whatever student work I'm looking at should reinforce you helping your students be successful on LEAP. That does not mean that they need to be LEAP-like questions, but like I would hope to see in your classroom that you practice CERs, that you're practicing different types of analytical thinking that you might see on LEAP, maybe trying out some questions that are similar to LEAP as well. So what I need to see is that your assignments require students to organize, interpret, analyze, and evaluate information rather than reproduce it. Now, my elementary school teachers always struggle with this because they feel like their students have to reproduce. But that's not necessarily the case. You can have your students analyze data, looking at bar graphs, and you can get them up to that level once they learn the scientific jargon and they understand the concept. You want your students to be able to draw conclusions, generalize, and produce arguments that are supported through extended writing. So we would like to see that the student work includes some sort of writing, if that's explaining their answer or debating something. And then we also want to connect with their learning to experiences, observations, feelings, or situations significant in their daily lives. So again, we're talking about the relevance of what they're learning to their personal lives, if that's inside or outside of the school. And of course, it's great when you display that work as well. Another section on the rubric, which would be expected, is assessment. So we want to see effective assessment. And what we want to see is when you are developing your lesson, we want you to answer the question, what do I want my students to be able to do as a result of my teaching? And how do I know that students learned what I taught? And that could look very different depending on the lesson and the teacher. This could be anything from a bell ringer from a lesson the day before to you doing an exit ticket. It could be multiple choice. It could be a presentation. It could be a fill in the blank worksheet. It could be your students organizing data and analyzing it. There's a lot of different ways that we can assess our students that are not just multiple choice tests. It could be presentations. It could be them acting out different things. What I do need to see is that your assessments are aligned to the state content standards. I need to see that your assessment meets the Louisiana state standard. You must have clear measurement criteria. What is an A? You need to measure student performance in more than 3 ways. So in the form of a project, an experiment, a presentation, an essay, short answer, multiple choice test. So again, that's where maybe your bell ringer, your exit ticket, and some short answers might come into play. We still want to see your students practice writing. And I think this is really important because writing is so important, not just in ELA, but across disciplines. And we need our students to practice writing in science and math as well. NIET loves portfolio-based assessments. I know that that is not common in a lot of classrooms here in Louisiana, but I will give you some ideas like science notebooks and other ways that you can meet that. And then include descriptions of how assessments results will be used to inform future instruction. So in your lesson plans, you can indicate how you're going to use these assessments to help you with future lessons. And then finally, we're going to discuss environment. Side note, for my teachers who've never taken a class with me before, I teach Education 441, which is multiculturalism in the classroom. This class basically focuses on this section, which is environment. And so if you are ever struggling with meeting and making a 3 or a 4 in environment, please contact me so that we can talk about that and really ensure that you are creating an environment that has clear expectations, where you're respectfully managing student behavior, where you're creating a loving and inclusive environment and a respectful culture within your classroom. So let's talk a little bit about that. In expectations, we expect the teacher to set high and demanding academic expectations for every student. Listen, I get it. You're going to do a lesson and you already know who is going to excel and who is going to struggle. But that doesn't mean that you can't create expectations that every single student in your classroom can meet. We're going to encourage our students to learn from mistakes. It's okay to make mistakes. Goodness gracious, they're going to make so many mistakes when they're doing experiments. But even calculating the molarity of a substance or measuring how far the ball dropped from the chair. We are all going to make mistakes, and what I want you to focus on is that that's okay in science. You're going to create learning opportunities where all students can experience success. Students are going to take the initiative and follow through with their own work. This is when making those lessons relevant to the student, making it relevant to their real life is going to be super helpful. And you're going to optimize instructional time and where you're going to demand better performance from every student. We're also going to focus on student behavior. Now, I want to make it clear to my students in this class that a quiet classroom does not necessarily mean a well-managed classroom. When we're doing science, it's okay to get a little bit loud. It's okay to get a little bit rowdy, as long as you can control when those students are being rowdy and loud and when you need to bring them back together. What I want to see is timely and effective management of student behavior, and that's critical, right? If you are asking, it's just like with my toddler. If I am telling my toddler he did something wrong, a few minutes after he did something wrong, he's not going to remember that he did that. He's not going to understand why I'm reprimanding him. You need to do it in real time. Your students need to be consistently well behaved and on task. That does not mean quiet. It just means that they need to be doing what they're supposed to be doing. Your teachers and students have established clear rules for learning and behavior, so you've made it clear what the expectations are if it's during a hands-on activity or if students are quietly doing independent work. You're going to use certain techniques such as social approval, cognitive activities, and consequences to maintain appropriate student behavior. The teacher overlooks inconsequential behavior, right? We don't want to nitpick a student who forgot they're not allowed to sharpen their pencil until you're done lecturing. But we also want to make sure that all students understand the expectations of the classroom. You're going to deal with students who have caused disruptions rather than the entire class, and you're going to attend to the disruption quickly and firmly. We also want to see you create a very welcoming and respectful environment. A very easy way for you to do this is to welcome all members and guests. I love watching you all when you stand in the front of the doorway and you welcome every single one of your students. You ask them how they're doing. You call them by the name that they prefer. You use the pronouns that they ask you to use. Those are such huge indicators of you creating a respectful environment. Your environment is organized and understandable to all students. And here's a big one for science. Your supplies, equipment, and resources are easily and readily accessible and well organized. I'm a huge proponent of stations. I'm a big proponent of teaching your students how to pass out materials and pass them back without losing any time. You're going to display student work that frequently changes. And your classroom is going to be arranged to promote individual and group learning. If that means, and I know it's COVID time, so it might be a little difficult, but we love to see when you give your students the opportunity to work in small groups and pods of 2s or 4s, and then also promote individual work as well. It's all about that positive classroom climate, and that begins with showing respect to one another. If the teacher is not respectful to the students are not going to respect the teacher. Teachers most often set this in motion when they develop a set of collaborative ground rules for the classroom and then model these for the students on a regular basis. What that means is you and your students discuss the rules. Maybe you come up with the rules with each other, or at least you get some student input if there's certain rules that you have to have because of the school that you're at. And then, of course, you're going to use a lot of nonverbal cues that indicate respect and interest. That could be your tone of voice, your eye contact, affirmative head nods, smiles, the wait time that you provide your students, the proximity in which you stand to your students. I'm a big fan of air high fives right now and elbow bumps when my students are doing something awesome. And even if my student is not doing something awesome, still trying to put a positive spin on things. We also are going to create a respectful culture. This is where your teacher-student interactions demonstrate caring and respect for one another. This is going to bleed into your student knowledge. It's also going to bleed into motivation. It's also going to bleed into other parts of the NIET rubric. We want to see students exhibit caring and respect for one another. I also would like to add that I'd like to see caring and respect for equipment, since we use a lot of equipment in science. And your teacher seeks out and is receptive to the interests and opinions of all students. So receiving student feedback and having positive relationships and interdependence characterize the classroom. So we want to promote respect in all situations, discuss student and teacher expectations, set clear objectives, define classroom etiquette, and encourage open dialogue. And that's a great way of creating a positive classroom experience. So that's it for the rest of the NIET rubric. Thank you so much for listening to this presentation, and I hope you all have a great week.